Hey guys, Mr. B here, and in this video we're going to be going over the Chapter 1 review guide for the first unit of General Science 1 on science skills. Alright, so number 1, the application of knowledge to solve practical problems is known as, so this was known as technology. Okay, remember that technology is when we use our knowledge and apply it to solve a problem that we maybe couldn't solve before. That is what we call technology, right? We usually create something. Number 2, which is not a branch of natural science. Remember, there are 3 branches of natural science. There's physical science, earth and space science, and life science. So of these 4 choices, social science is not a branch of natural science. Number 3, what is the purpose of an experiment? So, of course, we do experiments to do lots of things, but primarily it is to test a hypothesis. Now, we communicate data from our experiment for sure, but that's not the purpose. And to prove a scientific law, laws are not proven, so you don't really have to prove a law, because remember, between laws and theories, laws just tell you something that you're going to see in nature, but you don't need to really prove it. So, number 4, a representation of an object or an event is called, so this is called a model. Remember that models are basically representations of real things. They're just usually either physical and they're smaller, or they're concepts or something, but they help us visualize something a lot easier. Okay, that's what we call a model. Number 5, which value is equivalent to 5 times 10 to the 6th? So remember for this one, 5 times 10 to the 6th basically is 5.0, or just 5 with a decimal. And then we're going to move that decimal 6 places over to the right. And every time we move it, we need to add a 0. So we're going to move it 1, 2, 3, 4, 5, 6. Okay, so this decimal here is going to go 1, 2, 3, 4, 5, 6 places. Right there, I think. Just double check again. So let's actually zoom in here a little bit so you can see this a bit better. There we go. So it was originally here. We're going to move it over 1, 2, 3, 4, 5. Oh, I did miscount. 6. Okay. So this decimal is now going to be here. 6 places over, which means that when we're done, we are going to have a number of 5 million. So that is going to be letter C as our answer. All right. Number 6, what is the SI base unit of mass? So mass is usually measured in some form of grams, okay? But the gram is not the SI base unit. The SI base unit is the kilogram. It's not a common unit that you're probably used to hearing. Grams are at least somewhat more common. We do use those in science more often than kilograms, because a kilogram is pretty big. But, you know, if you're like a company shipping large amounts of things, they measure things in kilograms all the time. So, number 7, an electric generator produces 10 megawatts. This amount, supposed to say, is equivalent to, all right, so the prefix mega, you need to remember what the prefix mega means, okay? Mega means 1 million times bigger. So 1 megawatt would be 1 million watts. So 10 megawatts would be 10 million watts. So our answer here we're looking for is letter C, 10 million watts. Number 8, which of the following is a ratio of equivalent measurements that is used to convert a quantity expressed in one unit to another? So which of these is a fraction of 2 numbers that are equal in size, and then we use them to convert between units? This is what we call a conversion factor. Number 9, when the ratio of 2 variables is constant, their relationship can be described as. So this is basically saying that when we have 2 variables, and the fraction between them, so if you were to divide them from each other, you get a number. And no matter what those 2 numbers are, if you increase one of them or the other and you divide the 2, you're always going to get the same ratio, right? Which would be like 1 or something. That would be known as a direct proportion. Okay, that would mean that they're directly proportional. So as one goes up, the other is going up by the same amount or the same ratio, or as one goes down, the other goes down by the same ratio. That's what that is basically saying. All right, number 10, which of the following would best suit data that describes how a part relates to the whole? So this type of graph would be a circle graph, where we're looking at one part and how it relates to the overall thing. Remember that line graphs are used to find relationships between two variables. Bar graphs are good at comparing multiple things to each other. And circle graphs are good at looking at parts compared to the whole picture. All right, that's it for the multiple choice. Let's take a look at some short answer. Number 11, give an example of a case where the branches of natural science appear to overlap. All right, so real quick, let's remind ourselves what the three branches of natural science are. So the three branches are physical science, which includes physics and chemistry. Then we have earth and space science, which includes astronomy and geology. And then we have life science, which includes biology. Okay, so this question is saying, can you think of an example where maybe you have a topic that doesn't fall under one category in particular? It maybe is a mix of two. Okay, so think to yourself for a second here. Think you can think of one, and then I'll tell you the one that I have. Okay, so here's the example that I have. Let's say that you are a personal trainer, or you're an athletic trainer, okay? And you have an athlete who, of course, is injured, and your job is to, of course, rehabilitate them. So you, of course, are going to be dealing with their muscles and things like that, and their injury. That's biology. You're dealing with life science, muscle tissue, bone, blah, blah, blah. But you also are concerned with how they're running, how they're moving, how their body looks as they're, in their stride and things like that, and the motion as they try to rehabilitate to get back to a normal function as an athlete, which is physics, because you're looking at motion and energy and forces and how they're pushing off the ground and things like that. So we could say that a topic that would be considered more than one branch of natural science would be an athletic trainer. They would be dealing with life science, biology, and physical science, physics, as they work with an athlete's body. Okay, so there's one example, and there's tons and tons and tons of examples or topics that don't fall under one branch or another. That's just the one I can think of. So, all right, number 12, what is the goal of a scientific method? So the goal of any science or scientific method is to solve a problem, typically in an organized manner. But the goal of a scientific method is to solve a problem or gain knowledge about a topic/event that we don't know much about. Something like that. Okay, number 13, how are controlled experiments useful? So controlled experiments are where we have multiple variables that we keep the same, and then we only change one variable at a time. We run the experiment and we measure to see how that one change affects the outcome. So controlled experiments can be very useful because they can help us to narrow down what the main cause is of why something is happening. Okay, so we'll put down controlled experiments are useful because they help us to narrow down the causes of certain events. Okay, because once we check multiple variables, we can then determine what's causing this thing that's happening. All right, number 14, which of the following graphs describes a direct proportion? So we have this first graph, which kind of has a slope that kind of curves up and flattens out. This one's just a straight line going up. This one, which is kind of a curved graph as it comes down like this. And then we have this kind of S-looking curve. So remember that direct proportions are ones where we have straight lines. So this one is the direct proportion. I know we can type that. Can we type that somewhere? Oh, perfect. Okay, let's just type it over here. We'll just go this one. Okay, this is the direct proportion. All right. Number 15, a triathlete enters a race in which he swims 500 meters, runs 3,000 meters, and cycles 10 kilometers. What is the total distance of the race in kilometers? All right, so this is a conversion problem. They want us to tell them what is the total distance that this guy is going in this race in kilometers. And they're giving us one number in kilometers, but they're giving us two other numbers in meters. So first, we need to convert the meters into kilometers and then add them all together, okay? So to do that, we're going to have to do some dimensional analysis. So first, let's convert 500 meters into kilometers. We're going to need to know the conversion factor between kilometers and meters. So in case we don't know that, 1 kilometer is equal to 1,000 meters, okay? That is that's our conversion factor, which we can write as a fraction. So we're going to do the math. It's going to look like this. We're going to go 500 meters times, and then since we're starting with 500 meters, we want to put the fraction, this conversion factor, with the meters on the bottom. So we're going to have 1 kilometer on top divided by 1,000 meters, okay, like this, equals, and then if we do this out on a calculator, we'll get an answer of 0.5 kilometers. Okay, so if you take 500 divided by 1,000, you're going to get 0.5. So that's 500 meters is equal to 0.5 kilometers. Okay, so that's the first one. Then we're going to convert 3,000 meters into kilometers, and it's pretty much going to be the same math. Okay, so we'll go 3,000 meters, and then divide this by 1,000. Divided by 1,000. Oh, sorry, I'm sorry. I'm confusing you, I apologize. 3,000 meters times, there we go, 1 kilometer over 1,000 meters equals, and then again, if we do this on our calculator, we'll have 3,000 basically divided by 1,000. Okay, so 3,000 times 1 over 1,000. It's the same thing as 3,000 divided by 1,000, and we'll get 3 kilometers. So then from here, our final answer is we're going to take all of these and add them all together. Okay, so we have 5 kilometers and 3 kilometers and 10 kilometers. So 10 kilometers plus 0.5 kilometers plus 3 kilometers equals, so 10 plus 3 is 13, plus 0.5 is 13.5 kilometers is the total distance of the race. Okay, and this is our final answer. So if you are not good with converting between units using dimensional analysis like this, reach out to me so I can help you. Okay, it's a really, really, really important skill, and it's really not that hard once you get the hang of it. Otherwise, there's some videos you can go watch that will hopefully help you there too. So, all right, last question, number 16. The Milky Way galaxy contains between 200 and 400 billion stars. Estimate the number of stars in a cluster of 30 galaxies similar in size to the Milky Way. Your answer should consist of a low estimate and a high estimate, both expressed in scientific notation. All right, so basically this, all they want us to do is they want us to put these numbers into scientific notation, okay? So the Milky Way contains between 200 billion, so that would be times 10 to the 9th stars. Okay, that's scientific notation. 1 billion has 9 zeros. So we just go 200 times 10 to the 9th. That means 200 billion stars and 400 billion stars. So 400 times 10 to the 9th stars. So that's the normal range of the Milky Way. Okay, so this that we just typed out, that's this written here in scientific notation. Now if we have, it says to estimate the number of stars in a cluster of 30 galaxies similar in size. So basically what we're going to do is we're going to take 200 billion, okay, and I'm just going to write it in scientific notation. We're going to take 200 billion and we're going to times that by 30. And that will get us an answer of how many stars there would be, the low estimate. And we'll write it in scientific notation. So I'm going to do this on my calculator on my phone. Okay, I'm going to take 200 billion times 30. I get a really big number, but I get 6 times. So this is what my calculator shows me. Okay, I'm going to type it out here. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the number that my calculator gives me. So this is how many stars there would be. But it says here that we need to put our answers in scientific notation. So there would technically be a decimal right there. Okay, my calculator doesn't put the decimal on there, but that's where it would be. So I'm just going to move this decimal so that it's right here between the 6 and that first 0. And then I'm going to count how many times over I had to do that. Okay, so we're going to go, we have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So this is going to be equal to 6.0 times 10 to the 12th, because I had to move the 0 12 places over. Okay, this is our low estimate right there. Then we're going to do the same thing for the other one, the other number, though this is going to be our high estimate. So this is 400 times 10 to the 9th. So this is 4 billion stars. Okay, so 4 billion stars times that by 30. We'll get that number in scientific notation, and then we'll have our answer here. So 400 billion times 30. And my calculator tells me 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. Okay, so there's our stars, which we could write this in two ways. It's like the previous one. So we could write it as 12.0 times 10 to the 12th. Okay, we could write it like that. Or if instead of putting the decimal between the 2 and the 0, we could put it between the 1 and the 2. So rather than 12.0 times 10 to the 12th, this could also be equal to 1.2 times 10 to the 13th. Okay, let me just move this over one more. There you go. Okay, so this could also be equal to 1.2 times 10 to the 13th stars. And all I did was I took this decimal from this spot and I moved it over one place to the left, which then increased my number from 12 to 13. Okay, and I'm going to keep it like this because remember, scientific notation for the most part should be number, decimal, number. So I don't want it as 12.0. I want it as 1.2. So our final answer then is going to be, so we're going to say the number of, oh, let's not underline this. So the number, there you go, the number of stars in approximately 30 galaxies similar in size to the Milky Way would be 6.0 times 10 to the 12th stars, and I guess let's not underline this, that doesn't, it's easier to read, there you go, and 1.2 times 10 to the 13th stars. Okay, so the number of stars in approximately 30 galaxies similar in size to the Milky Way would be, would be between 6.0 times 10 to the 12th stars and 1.2 times 10 to the 13th stars. Okay, that is our final answer. That's what they're looking for. They wanted us to give them an answer of how many stars would there be approximately, and just record your numbers in scientific notation, which is, that's what we have right there. That's our final answer. Okay, so hopefully that made sense. But again, if you have any confusion or you just need some help with the math and the numbers, please, please, please reach out to me. I have no problem helping you. You can email me. You know, we can chat in class, in person. I have no problem doing like a Google Meet with you and doing some practice problems together. I'm always here to help you. So anyway, that's it for this one, guys. Hopefully that helped. And yeah, anyway, so I'm Mr. B. See you in the next one. Bye.